For our project, we have created a program that can generate texture. Texture is some visual pattern on an infinite 2D plane which, at some scale, has a stationary distribution. Given a finite sample, the goal of our program is to synthesize other samples from the same texture. Texture is traditionally either classified as regular, repeated textiles, or stochastic, without explicit textiles. Our program can handle both using our simple algorithm. Texture synthesis has many different possible applications, such as occlusion fill-in, lossy image and video compression, foreground removal, etc. An example is textures in video games. Oftentimes, the textures in video games used for large objects, such as skies or fields, simply repeat a small texture multiple times over a large area. With texture synthesis, the area becomes more diverse and realistic, adding to the immersion of the game. Our algorithm takes the original texture and divides it up into patches. It then begins building the new texture one pixel at a time. The first pixel is randomly selected, but every other pixel generated uses its surrounding neighbors to compare itself to the original image. It finds the best match and makes the current pixel the same grayscale value.
Here is an example of our program in action. We specify the input file, the output file, the patch size, and the size of the new image we wish to be generated. Our program takes a little while to run, so we'll go ahead and skip to some previously generated examples. Here on the top row, we have our textures that we retrieved from texture sources on the internet, such as Brodats or Iverson Lung's library of textures. Along the bottom, we have our program's generated textures. Thank you. This was texture synthesis.